Good morning. Proportional unit proportional relationships, student handout number 5, proportional relationships. So basically we're just putting it all together. Everything we've done so far is kind of putting it together. Proportional relationships. It represents what we've already talked about in a constant rate of change. Two things will be true about a graph that is proportional. We've already covered this. The graph will be a linear line, aka straight, and they will pass through the origin. Oops, I forgot my I. Aka 0, 0. So in a table, we want to check for equivalent ratios. In other words, in a proportional table, the ratio of y to x will always be constant. Here we go. The number of miles a deer, well, it's hunting time, so the miles that a white-tailed deer travels is shown below. Complete the missing information and then answer all of the blank parts there. All right, so they give us a table, so we can fill that out. All right, we have x and we have y, so we can fill in all the missing parts because we have y over x, which is 84 over 3. And we can figure out the ratio there. And when you do that, you're going to simplify into 28 over 1. 3 will go into 84 28 times. So you divide by 3 on each. Or just in your calculator, go 84 divided by 3. It's going to tell you 28 over 1. So for every 1 hour, it's 28 miles. For every 2 hours, you double that, it's 56. And then just go down the table, which we've already done before, so I feel like you got that. And so the y over x of all of those, when you simplify them, will be 28 over 1, all of them. So you need to figure out the rate per 1, and then you can fill in the graph. Well, what if 1 wasn't on there? Well, we know what 1 is, so we can figure out what 2 is. All right, so let's go graph that. The x is hours, and the y is miles. So for every 1 hour, so 1, 2, 3, 4, 5, 6, 7, all the way to 9. I'm going to count up by 28s. Why? Because that's what my table goes up by. And I want to make a pretty graph. Do I have to do it this way? I do not. But unless you want a pretty ugly graph, I would do it this way. All right. 128, go ahead and graph those. Remember how to graph those. I'm gonna come back over here. I'll go back to the graph in just a second. Remember it is x and then y on your coordinate plane. So it'll be 128, 256, 384, so forth, okay? All right, so we got 128. I'm gonna use the red to graph these. 256, 384, so forth. See how my graph's all pretty because I lined. All right, and then I do want to clarify something. Notice down here in yellow, There is not an arrow because it does not keep going. If he travels 0 hours, he's going 0 miles and ain't going to keep going past that. That is the starting point. Sometimes there can be an arrow there depending on what we're talking about. But in this particular instance, at 0 miles, it's 0 hours. 0 hours at 0 miles. So there's not an arrow on the bottom. There is on the top because he can keep traveling. He can keep going if you don't shoot him. All right, the equation, remember it was y equals mx. So it was y, and then m is the rate of change, aka one day you will learn that as the slope. So y equals mx, y equals, what is the slope? What is the rate of change? It is 28 over 1, which is just 28 times x. That's it. That's your equation. What is a verbal description? How would we say it if we were to tell somebody? We were to say a white-tailed deer travels at a rate of 28 miles per hour. All right, when it asks for proportionality, how do we know it's proportional? That's what it's asking here. 3 things to know it's proportional. It has a constant rate of change. (28 miles per hour). It's a linear line. And it passes through the origin. All right, I'm going to pause. I'm going to zoom out first before I pause, so if you didn't get any of that. I'm going to pause now, and you and your partner do the backside. Same thing, same exact steps and everything. So you and your partner do the backside. Go. All right, welcome back. Let's get it going. Notice on this one, I don't know if you did notice, but there's no labeling of the table, because they give us a verbal description. So we have to gather information from that because they didn't give us any of this. All right, the student council is selling t-shirts to raise awareness for the local animal shelter. For each t-shirt they sell, they will donate $7. So for every one, it is $7. Well, if they sell 5, how many is that? 5 times 7 is 35. And you simplify that as 35 over 5, which is 7, which is exactly what they said. 7 over 1, which is 7. So they sell 7, or donate $7 per. So 10 times 7, 15 times 7, 20 times 7, 25 times 7, all the way down. Why am I doing it times 7? Because it's $7 per shirt donated. So we got 105, 140, 175, 210, 245, 280. Now, I'm not done because I need a money sign because we are talking about money here. Now, we still need to label them. So what are we talking about? We're talking about number of shirts and how much they donate. Oops. So, number of shirts sold, total money donated. All right, so let's graph it. Remember X and Y. So we're gonna count by fives on the X. And that was t-shirts sold. All right, and up top, side, Y, I'm gonna go by 35s. 105, 140. Now, notice I'm not gonna put the money sign on the graph here because when we're dealing with graphs, we don't put the money sign. We know it's money. When we put the answer, we will put the money sign, but we do not put the money sign on graphs. All right. Now let's graph it. If you don't remember how, remember, this is the X, this is the Y, so it's 5, 35, 10, 70, remember? Okay? Yes, in this instance, it does make a pretty little straight line, every dot, one up, one over. And then go ahead and draw your straight line. Let's see if I can do a straight line at one pin. Close. Notice there is an arrow at the top, no arrow at the bottom, because if we sell 0 shirts, we make $0. But it will keep going. The more shirts we sell, the more we donate. Now, this is the rate of change. The rate of change is Y equals 7X. That's the equation. Y equals the rate of change X. Okay? They already gave us the verbal description. Now we just need to tell everybody why it's proportional. 3 things: linear line, passes through origin, and the third one, constant ratio of 7/1 or just 7. Linear line, pass through the origin, and constant rate of 7. All right. You and your partner try 3, 4, 5, 6. And the last one says 6, but it's actually number 7. See if you can get those. The 3 things that I need you to tell me if it's proportional. And if it is, I need you to write the equation. The Y equals whatever the number is, X. And then I need you to tell me what X represents. So I'll go down to the bottom one. A vehicle travels at a rate of 65 miles per hour. Is that proportional? Do they drive 65 miles every hour? Yes, so that is proportional. It is proportional. So now I need to write an equation. Y equals the rate of change, which is 65X. what does X represent? X represents the number of hours driven, and Y represents the number of miles driven. So it is proportional. Y equals 65X. X represents the number of miles driven, and Y represents the number of, X represents the number of hours. Excuse me, screwed that up. Y represents the miles traveled. If you don't know how to do that, let's think about it. If 65 is the rate of change, that is 65 over 1. It is Y over X. 65 is miles. 1 is hours. So you can figure out what they mean that way by figuring out which one is Y and which one is X, by putting it into the ratio. All right, you and your partner do 3, 4, 5, and 6. Pausing now. All right, welcome back. Number 3, a restaurant charges $10 for a medium pizza and then $1 for each topping. Is that proportional? That is non-proportional. And let me explain. That is non-proportional because you don't pay $10 for everything. You pay $10 for the pizza and then 1 per topping. So it's not going to travel through the origin because it starts at $10 because that's what you pay. Yes, you're going to pay $1 for every topping, but you're paying $10 for the pizza. So you're going to start at $10 and then add $1 for everything. So you'll never pass through 0, 0. Because you don't add $1 for each topping if you don't buy the pizza. They go together. All right, number 4. A restaurant has an all-you-can-eat buffet. Oh boy, that sounds pretty good. They charged $8.75 per person. Per person. Anytime you see that per, that's probably proportional. Unless there's a fee at the beginning. Okay? So is it proportional? Yes, it is proportional. Why? Because there's no fee at the beginning. It's just, I can't spell proportional. I misspelled it up top too. Look at that, I still can't spell. My gosh. P-R-O-T-O-N. All right. Here we go. So what is the equation? It's going to be Y equals whatever the rate of change is, which was 875x. What does Y represent? Y represents, I'm going to put X above it. Y represents if you don't know, let's go over here to the side. It's Y over 1. So what is 8.75? That is the cost. And the bottom is the people because it's $8.75 per person. Okay, so Y represents the cost. X represents amount of people. A restaurant charges $1.50 for a fountain drink with free refills. So are you going to pay $1.50 a fountain drink? Every one of them. And guess what? You're not paying per refills. So it's just $1.50 and then you get a drink and unlimited refills. So is that constant? Is that changing? It is not change. It is proportional. because no matter how many drinks that you buy, right, you're going to pay $1.50. No matter how many refills, $1.50. So it is proportional. So y equals the rate of change. So 1.5x, or 1.50 if you like that 0. Y represents, if you're not sure what y represents, go over here in yellow again. It's 1.5 over 1. So it's y over x. So y equals the 1.5. What does the 1.5 represent? It's the drink. Over what? How many drinks? Number of drinks. So y represents the total cost. And x represents number of drinks. A restaurant, number 6, last one. A restaurant has a build your own salad option. That sounds great. It is $3.80 per pound. $3.80 per pound. Is it proportional or not proportional? Does it change, or is the cost the same? The cost is the same no matter how many pounds you buy. So it is proportional. And then y is going to equal whatever the rate is, so 3.8x, or 3.80 if you like that 0 at the end. It is $3.80 per. That word per right there generally means this is the top, this is the other is the bottom, generally. Okay, but it's $3.80 per pound. So $3.80 on top, pounds on bottom. So what does x represent? X represents number of pounds of salad, but you can just put number of pounds, and y represents total cost. All right, it's all the fat guy in the bag wrote. I'll see you on the flip side. Adios, amigos.